Welcome, everybody. This is the KubeVirt community meeting, August 19th, 2020. First up on the agenda, I will turn it over to Chris to mention Minikube Quick Start.
Yes, hi, I'm Chris. Just wanted to put a quick mention out there that we've updated the KubeVirt on Minikube Quick Start page. The URL is in the community meeting notes. Try it out. Let us know how it works. That's it. Thanks.
Awesome. And that is version, for the latest version, 32?
Always for the latest, yes.
Awesome.
This is quick start, so we don't get into those gory details.
Exactly. Make it nice and streamlined.
Mm-hmm.
All right, so the next topic is Daniel Belenke would like to discuss component testing.
Yeah, hi. So I don't remember if we raised it before, but as you probably know, there are currently ongoing discussions on making our API stable, like V1. And once we have a stable API, this actually enables, or opens the path for component testing. And by component testing, I mean that we can take each of our components, isolate it, and write like contract testing to test the API of this component as a standalone piece. And it can allow faster feedback loop for local development because those tests are usually fast. And they can be a very good addition to the current tests that we have on the CI.
So I have a question about that. What about moving our API to V1 enables this component testing?
Because when until we have a stable API, we don't have actually a contract that we can say, okay, this is our contract that we want to test. In theory, but actually, when you say it, maybe we can even not wait for a stable API and start with what we have now. I'm just afraid that the API will change under our feet while we try to implement it.
At least on KubeVirt itself, the API is stable. What I wonder is, I mean, we don't have it V1 yet for a few reasons, but not because we want to change the API. What exactly do you plan to do there?
Well, I don't have the full plan, but the idea is to be able to test each component standalone. Like, for example, take Virt Launcher, run it in a container locally, just Virt Launcher, and
basically mocking the other components and executing some scenarios. Okay. Sounds helpful, yeah.
Yeah, just wanted to hear the feedback on it. I think that it can be a good addition. Like we have unit test, we have end-to-end test, but this goes somewhere in between.
I think there was a request on this forum some time ago to replace Virt Launcher with something custom, wasn't there? So once we have such an API, an internal API, it would allow them to do so.
It wasn't a custom Virt launcher. They wanted to run the Virt launcher binary in a custom container. So basically start over and build it on something other than Red Hat Core OS, I believe.
Ah, gotcha.
Yeah, I think, yeah.
Go ahead.
No, please go ahead.
Oh, I just wanted to say, I mean, we have the gRPC interface. I mean, one can just use the Virt Launcher binary, modify it, use another base image with another libvirt QEMU and just exchange it. Even on an installed version already, like you can just change the Virt controller deployment, the other image. So from that perspective, I think we're good anyway. If it's really about Virt Launcher replacement and not about something completely different like they wanted to do.
So with which component would you start, Daniel? I'm just
I think that
curious.
I just think that Virt Launcher is the easiest one because that I think that it does the least of interaction with Kubernetes itself. And for example, you can't just run Virt handler locally because it does some Kubernetes API calls, and we will need either to mock them or to run it on Kubernetes, which is fine, by the way. It doesn't have to run directly on a container locally, but it would be cool. What I mean is that it could be cool to take just single component and with a well-defined contract and just test this. So for your question, I think that Virt Launcher is
With that, I'm worried because, like, at least for networking, there is a close bond between the handler and launcher. So the handler creates something in the launcher, and the launcher then takes it and does something different. So it's like it's close to the OS and to the system. So maybe it would be easier to just test the other part of the API where we can just run a Kubernetes API server locally and test only the APIs. So there are no side effects regarding to the system.
Yeah, it's another possibility. So you mean to run them not on Kubernetes, but to run the Kubernetes API server locally as well?
Yeah,
So
yeah,
there's
sorry, go
something
ahead.
nice on the Kubernetes, and which are static pods. In theory, you could look into running the kubelet, Virt handler, and Virt launcher together, and that would be pretty fast because most of the time on our tests, at least if we don't wait for a VM to fully boot, most of the time we just wait for the scheduling and everything. So it should be significantly fast already.
Yeah, we do this kind of testing on one of the network components where we just spin up the Kubernetes API and maybe kubelet and just test the API standalone. So you kind of test the application really, but for the most part, it should be sufficient.
I don't think that we should. It is not a replacement for end-to-end tests. It is just, so with end-to-end test, for example, it is very hard for you to cover the entire API and all the different branches, let's call it, in the code. Like if you have a condition, so you already have 2 branches that you need to test. And if you will want to test all those different branches in the code with end-to-end tests, it will result in thousands of various scenarios that will take a long time to run. But if we introduce this framework for component-based test that can test, so this test will just take care of testing the contract, and by contract, of course, the public API, and eventually the public API is also tied to some internal implementation. So different API endpoints or different values to different API endpoints will allow us to cover the entire internal API, internal code flow in a way that is a bit more, how will I call it? It will give us a better, a closer result to the real application than just unit tests, where we entirely mock the Kubernetes API server. And for example, one example that I encountered recently, which was problematic in the unit tests, and we could solve it by having component tests, is that the Kubernetes fake API server doesn't do role checking. So if you forget to add the role that you need, the unit tests will pass and the calls will be registered on the API mock object, but when you run the end-to-end test, it will fail. So it's like another layer in between that that in theory should allow us to reduce some of the lanes, not lanes, but some of the tests that we have in the end-to-end tests and move them to component tests. And then in the end-to-end tests, we just test like the general flow. That
Yeah, on that last part, I'm not so optimistic, but yeah,
yeah,
we can at least try things out. How far
yeah,
it goes.
I don't want to remove end-to-end tests. I just say that if we, for example, today we want to test the API of some component, and I don't even want, for example, to start a VM, but I just want to see how Virt Launcher communicates with Virt Handler. And the whole VM part is irrelevant for my test. Today, I still have to wait for the VM to start or stuff, but we still do it. At least.
I think it's a good exercise to map the how interconnected are all the components, but I'm not too optimistic that we'll be able to decouple them, like the launcher and handler. Maybe
it's okay. I don't want to decouple. This is why I also just propose it, for now.
So I think there are a lot of especially on the node area, there are a lot of hard to reproduce scenarios where we could do better on testing, which would be time consuming in many ways, especially error conditions. And it might be nice to have the chance to have Virt Handler and Virt Launcher ready there, where fake VMs are spawned and return something to libvirt, and we can exercise some error conditions more extensively. That's definitely nice.
Yeah, I mean, I think that part of the thing to keep in mind is that you're trying to break the system down into functional areas that can be tested independently. It doesn't mean that every single individual little small component needs to do that. But if you can take, 2/3 of the system and isolate it and focus on the third that you're interested in, that can save an awful lot of time when somebody is trying to figure out, does everything behave the way that it needs to before I'm ready to do the full end-to-end test with everything in the pipeline. So I agree. I think it would be great if we could get some of that capability. And it can be incremental. You could just have a very large functional area, and then if you see benefit, you could break that down into smaller functional areas as the opportunity presented itself.
Okay. So I think, Glenn, I think that you phrased it very well, better than I could. I think. Thanks. So I think that I will take it as an action item, and I will see if we can do something in that direction.
Sounds good.
Okay, and I think we've pretty well exhausted this conversation, but last call if anybody has any thoughts.
Sorry, what was the topic of the conversation?
So we're talking about component testing.
Okay, that's enough. Sorry, just to thank you. Then I just wanted to make sure. Thank you.
Okay, so next topic, revisiting the multiple binary situation. I'll turn it over to Roman.
Yeah, I just want to give an update here. So the issue was, so a summary first. We had the interesting situation that we released first a virtctl binary with an AMD 64 ending. Then we released a virtctl, and later releases we released AMD 64 ending binary and x86 64 ending. So, but x86 64 and the AMD 64 are supposed to be the same thing. And then on the latest release, suddenly the AMD 64 binary disappeared. So we definitely want to continue releasing the AMD 64 binary, and it's now also released on the release 32 branch where it was missing. And we changed the code so that only this one will be released now. And the issue that the other one got released was that on that although Golang does not support AMD 64 in that sense, it doesn't support x86 64 in the sense that it's written somewhere, you can specify it, and it just interprets it as AMD64 or something. I don't know. So it was fine with passing that, but it's not, x86-64 is not even listed on the Golang side as supported, just AMD64, which is the same thing. So we just continue with AMD64 since it's also there. And so no documentation needs to be changed on the KubeVirt.io documentation anywhere, and also no need to change the crew plugin or anything. And all releases should have the AMD64 binary at this stage.
Just to clarify that, are we dropping x86-64?
Did you mention it already somewhere now?
It might be. I'll have to scan the website code to see if we have any mentions.
As it is right now, it would not appear again. And
okay.
It was an
All
accident that it was there before. If it's really necessary, we can also reintroduce it, but it's actually confusing, as we've seen, because people then ask themselves, what should I choose now? And,
right. And they were different. So.
Yeah, and they were different from the size. Yeah.
Okay, I'll take on scanning the website and replacing any instances with AMD64. Thank you for looking into that.
Okay. Sorry, I was typing in that last note there. Is there anything else that we want to cover in the agenda and notes today?
I've got one topic I want to raise. David, just as you listen up front, and Roman, also to call you out. I think what I would like to explore is just to use the time wisely, right, is the ideas about disruptionless updates or reducing the interruptions for launcher updates. And I think David took some time to look into that topic, and I just wondered if we wanted to speak about that topic a little bit here, which might be also interesting for Peter, because it's also what network. Oh, and I see Vladik is also here, and Michael as well, so we have all domain experts here. David, have you looked more into the MMFD and whatever discussions?
Yeah, so that's an ongoing discussion. I don't have a whole lot of information to provide yet, other than the theory behind what I'm looking at. Do you think that's useful now, Fabian, or should we wait until we know a little bit more? I don't mind sharing.
I would share it. I think maybe to give an early heads up to especially Peter and Michael to think about their respective areas. That might be interesting. So and the crazy, and it's just a great crazy thing to explain, I think.
I think it makes sense to first highlight that what you probably are talking about is after you have updated KubeVirt, you don't necessarily have to update VMs, but if you update them, you get new QEMU versions with potentially new features. So this right now requires a restart, right? Is that what we're talking about?
A restart or migration. So what happens when we update the KubeVirt control plane, or just when we update KubeVirt, the whole control plane rolls over and you get new Virt handlers and controllers and APIs and all that. But the components that live with the virtual machine workload inside that container, or inside that pod rather, they stay the same, because the only way to update those right now is you have to tear down the virtual machine and essentially start a new pod with the new updated components in it. So that means either live migrating a virtual machine in order to get the new Virt launcher and QEMU and libvirt, or stopping the virtual machine and then starting again. So both of those are disruptive to a certain extent. What we're looking at is if there's a way to potentially update the components that are connected to that workload, so libvirt, QEMU, and Virt launcher, while the virtual machine is still running. So use that same pod that the virtual machine is running in and essentially just kind of swap out all the guts to it. And I don't want to get too detailed into how we could do that part of swapping the binaries and all that. The fundamental mechanic that would allow this is to do something where we can live migrate a QEMU process to another updated QEMU process within the same pod environment, and do so where we don't duplicate the memory twice. So if we can swap out that PID to another PID, then we can figure out the rest. But that's the hardest part. So we have to figure out if it's possible to do a localized migration of QEMU to another updated QEMU binary and share the same memory and everything in a way that there's no added resource requirements required to do this.
How big are the chances there that if new features get added, that they would then work with the new QEMU?
New features get added. Explain that.
I think the assumption is that QEMU or all those components really don't change because we mainly aim, to do that on minor updates. I don't think, looking at like major version upgrades, but rather like, security fixes or something like that in order to reduce the overall number of VM interruptions that might occur over the life cycle of a VM. Does it make sense?
I think the main challenge for me, at least, is to make sure that both of the VMs will not write to the same memory. I mean, if we're sharing the memory, we'll need to have some kind of a mechanism to make sure that both of them cannot write to the same place.
Can't it actually be a live migration, though?
How would you then have the memory not duplicated to a degree? Wouldn't we then have to take some additional buffers for memory overheads and all this into account? Just thinking about the C groups here.
So the thing is that the QEMU team, I mean, there was some work by the QEMU team, right, to effectively say you share the memory between the QEMU instances. So we for sure have to take care, for example, we know about the VGA buffers, right, that we need to allocate for the graphics card. And I don't know, for SRV devices, we know the buffers. So let's ignore them for a second because we assume that the guest memory is the major memory hogging part, right? And the idea is that, or the QS team said that there might be the chance to keep that memory, in the host's memory, and reuse it from the new QEMU process, right? So that means we don't need to duplicate that guest memory, which is largest chunk. And that's actually what what is the enabler for this kind of approach, right? That we don't need to duplicate it, because otherwise that would be a blocker.
Fabian, you said that the QEMU team is working on some sort of a handoff between two QEMU processes?
Let's be careful. I'm not saying they're working on, they hinted at, right?
Yeah.
That they thought about it. So it's very vague, disclaimer, very, very vague. I'm not saying that anything is there, but that is what they mentioned, right? That there are ways to possibly do a live migration on the same node when the memory remains where it is.
Yeah.
So
because just moving, sorry.
Go ahead.
No, what I wanted to say is that just moving the QEMU process between containers shouldn't be too hard. But
the process is the thing we want to kill, right? Because the process is what we need to renew. We effectively need to load the new binary from the on disk. Yeah.
Yes, I know. This is why. So my assumption is that we are not going to do something that QEMU does not support directly. And so besides from, at least how I see it, besides from moving the QEMU process to a new container and spawning a newer version of QEMU there and letting them do the handoff of the VM, what can we do?
I have another question.
Sorry,
here.
I think that's a major achievement if we manage to do that, right? I mean, that would be awesome.
I have another question here. Do we, as far as I know, that normally when you update Kubernetes nodes, no matter if Kubernetes upstream or OCP, you normally evict a node anyway. Do we expect that we roll out? Do we expect that people roll out KubeVirt security patches that more often than Kubernetes security patches? That this is very important for us?
Yes, I think that is something that we can expect, right? So we know that the life. I mean, it would be interesting if we can get some data to it. But yes, I mean that's the use case, right? To assume that that there are security fixes for KubeVirt specifically that don't require the cluster to be updated.
Also assuming that we don't have to somehow coordinate the update of KubeVirt with the cluster update. That's
Yeah, I'm
it's a
mostly
little
just
complicated as
worried about additional complications.
Oh,
For
sure.
me, it basically means that when a feature like this is introduced, we would basically have to pretty much test every feature we have always, also against this way of updating.
Right. There's just a it's so complex and it's such a daunting task, I think, right now, that's why I was hesitant to even bring it up quite yet until we had a little bit more tangible knowledge of what we can and can't do.
So without more info on how good something like this could work, or how stable, or how good pre-tested on the QEMU side, I would be very scared to introduce much more issues for users if we introduce this than compared to the other one. But,
right.
Yeah.
I think we're in agreement on that.
One thing that we could try is maybe if we allow some downtime, we could migrate the VM to file and then restore it. I mean, automatically.
What would be the difference between doing, well, okay, I see, because it would be an entirely new pod environment. We would back it up to a file and then start a new pod and restore it from that file.
Yeah.
Well, if we can replace the binary, then you could even do it in the pod, right? You would just serialize it to file, replace the binaries, and unserialize it.
I would contest that saving the file is increasing the resource footprint, which is something we're trying to avoid.
Memory and CPU footprint is more important in this case. I agree than the storage footprint. They're all important, but the things that are really limited is going to be memory and CPU.
But one thing that maybe is a bit not exactly the use case that you specified, David, but many times we see actually CVs coming not only from QEMU, but from the image that we use to run the process in. So, and I think that just spawning a new launcher and moving the QEMU process from one namespace to another is achievable. And I think that it also has some value in this direction because it will allow us to start with a newer base image and eliminate CVs from there.
Yeah, some of the theories that I've been working with here are to launch the Virt launcher pod and the environment that the actual QEMU process lives in separate pods, and kind of decoupling those two things, and then injecting, like maybe through a bind mount or something, all the guts of the Virt launcher container into this kind of skeleton environment that just has the allocated resource limits and requests for the QEMU process. So the QEMU process would essentially be running in a pod that doesn't have anything in it other than what's been injected into it. So if that's the case, then when we look at like updating or things like that, it's just a matter of stripping out and launching a new Virt launcher pod next to this environment. That's the theory, at least, just to give some context into what I'm thinking.
But you still don't update the environment which QEMU will run in. So
right, yeah.
Yeah, I understand. It's
yeah. So there would be nothing in that environment, though, as far as like binaries go. I think I'm not entirely sure how that would work. It's a theory. If we could launch essentially something that is nothing and inject even the entry point at startup.
Yeah, got you. Thanks.
My only comment is we've talked about these sort of possibility of optimized local live migrations for hot plug. And this, I think, is different because you'd be doing it in the same pod, right? But I'm wondering if there's a way that this could, potentially, obviously there's lots of research. It could also be applied to the hot plug case in another pod.
The hot plug case, we needed to start a new pod because that's the only way we could go through the normal means of attaching a PVC to the pod. So I think we're still kind of in the same place with hot plug with this new method. We reuse the same pod environment, then we're not able to attach new PVCs, but we're using a similar mechanism, like the stuff that your team is investigating with hot plug with companion pods.
Mm-hmm.
That's kind of the same theory behind how we would update the Virt launcher and things like that.
Okay, but I mean, the PVCs are just one thing that potentially for hot plug, I guess.
Yeah, that's true. There's also network and other things.
Okay. Without any other thoughts, moving on to the next topic. Edward has mentioned Docker versus Podman for testing.
Yes. So I only had a small question or a request because we need to give some third-party vendors, I would say, to test our KubeVirt. For example, giving at least this is a need from the network side, and we found a problem while testing this, that the test runs they are Dockerized, and they are Dockerized using Docker. And this causes some problem if we try to run it on things that don't have Docker there, like Red Hat RHEL 8 or other OSs that don't have Docker installed by default. And the question is, is there any option to move to Podman, at least in the Dockerized part of the building and the testing?
So this was actually explored, I'd say about a year ago. The team member who did this has moved on, but he did manage to run KubeVirt as a whole in Podman using the Varlog socket, I believe it's called. So there is prior art to doing this, but right now I think that code may have bit rotted at this point. I don't think it was ever merged. So I personally would love to be able to use Podman just because it is kind of inconvenient to get Docker locally.
For test, so for really just compiling KubeVirt and running the unit tests and everything, there should be no need for Docker specifically. So if that is what you mean, there is nothing there's nothing like nested Docker or so. You may even get away with just replacing any Docker mention with Podman, since the API is mostly compatible. And it may just work out of the box, but there should nothing, even if not, there should nothing be blocking. And
I think I've actually tried this, and what you're going to run into is that we, even with the Dockerized function itself inside of hack Dockerized, waits for the for a socket to be considered ready. So it's more than just a simple text replace, because there is some nuance that we need to account for.
Yeah, I mean, there can be some things, but there is nothing so complicated like with KubeVirt CI.
I think that the only, well, I tried it a while ago, and as Stu mentioned, the only thing that was preventing me from achieving this was the missing Docker socket for Podman. But I know that today, I think that Podman can create some sort of a socket or something similar. I'm not sure. And
do you, by any chance, remember where we were waiting for a Docker socket in this case? Because hack Dockerized should not have nested Docker in any way.
We tried this, or I tried this probably.
You can't
18
use it with
months or
make
more
cluster
ago.
up and make cluster think, just that we are sure that we talk about the same thing. Make cluster up, make cluster think is a different story. But just make test, and all that should work.
I
There is
believe that
no.
they didn't, but I can't swear to it.
No, I'm talking about Go CLI.
Okay, yeah, Go CLI is completely, yeah, that's what Edward was talking about, make and make test, right?
No, so the goal is for the vendors to run. They need to run Go func test. So that's my.
The func tests, yeah, the func tests. That needs a lot of working.
They already have a cluster. The notion is that they have their own cluster deployed with their own stuff, and they add KubeVirt to it, and now they test it. So the cluster is already there. They only run the func test against an existing cluster. So, but they cannot run the
okay,
func.
There is no Go. So they want to compile KubeVirt and install it there on this external cluster and run it, or they have KubeVirt also installed already.
No, everything, they install everything. They install KubeVirt, they have already Kubernetes, and on it they install KubeVirt. The only thing that they need to do is to run something, they need to run the test against the.
Okay, in this case, cluster. It should be as simple as just going into the tests directory and write go ginkgo build, whatever, and then get the binary and just executing the binary. There is no magic involved. But even if you want more, there is, for as long as you not try to bring up your own cluster with cluster up or something, there may be something in there where we may need to change the command line a little bit, also but we work with Podman, but I really don't know of anything special which you use here.
Okay, I will, there is a PR documented how to run against an existing cluster, and that document uses Dockerized one-liner that is Dockerized, so maybe we can convert it to a simple Go test, but I will take it offline then and check it out.
Yeah. So I personally think both things are good. Just compiling the binary different without our hack Dockerized, because it's really just plain Go code which you compile the binary. But it's also having the possibility to, for instance, even dynamically detect if Podman or Go Docker is installed, and just switching then the Docker commands on demand is also fine in hack Dockerized from my perspective.
Yeah, I think that the advantage of the Dockerized one is that everything is already there. Like you don't need to think about what Go version you need or anything like that. It's everything is Dockerized, so the other vendor does not need to prepare anything. It just runs it, and that's it.
I agree. So if it just works with Podman too, this part at least for now, that's definitely an improvement in the right direction. That we don't necessarily have to use Docker there.
Okay, thank you.
So I missed it. What's the socket needed for? Is there a reason that we have to have it? I thought it was only there for ready.
With hack Dockerized, there should be no socket used.
In Go CLI, you need it for the to do API calls. This is how you communicate with Docker.
I guess the same Dockerized is used for both, so maybe that's the problem. Maybe, like if you use the same Dockerized.
So there is hack Dockerized, which just runs plain Docker commands for creating, for pulling the right builder image, mounting the right volumes, executing the right commands. But there is no magic at all. With GoCli, it's a little bit different. And GoCli is just used for spinning up and managing our test clusters. GoCli is shipped in a container already. And GoCli just assumes that on the host system, Docker is running. And that when GoCli started, someone ensured that the Docker socket is passed into it so that it can talk to it. So this tool depends much more on Docker than hack Dockerized, but there is no connection otherwise.
We'll have to investigate more than to check this out, because currently it doesn't work for some reason. I think Peter tried it and it didn't work.
Yeah,
Yeah, I saw
check-in
the
for
issue
sure
with
is
the
good, thanks.
socket.
Okay, I guess we have to take that one offline. Are there any other topics to cover on the agenda and notes before we move to the open floor? All right, turning it over to Pep. Talk about KubeCon.
Yeah, very brief note that KubeCon Europe is virtually ongoing. We are halfway through this week. Yeah, and there was a relevant announcement related to KubeVirt, which is, well, Red Hat announced the availability of a product based on KubeVirt components for OpenShift virtualization. So it's a supported product to run VMs on the Kubernetes version. Well, Red Hat's version of Kubernetes OpenShift. That's an announcement. That's basically it. There is if you have a pass for the conference tomorrow, there is a session, a breakout session where Fabian and Marcus will present KubeVirt. So you're all invited. You're still on time to join and see it.
I just want to say this is actually, no, never mind. Yeah, looking forward for your attendance.
Okay, well, thanks for that note. And next up, we have Roman to talk about CI capacity.
Yeah, so we are on the limit, as many of you see every day, and there are a few reasons for that. I just wanted to.
Yeah, thank you.
Pardon?
I was just about to ask, I did ask why, and then you said there are a couple of reasons for that.
So, I mean, when we came from Podman to IBM Cloud, we got more servers and also more engineers, but the engineers were still pretty new. So their PR-related output was not that big. So the situation was pretty good then. But luckily, engineers are getting more comfortable, so they're creating more PRs. That's one reason. Another reason is that for some time, we already have an interesting issue where with Kind, and this issue is now pretty bad for us for some time now because the IPv6 test lane is using Kind, and that requires much more watch resources on the node, which has implications, and it is also much more vulnerable to an issue which we're seeing for a long time, and this is that every few hundred times when you start a virtual machine, you get a strange def null permission denied or def kvm permission denied, and we don't know the reason for that. So this is pretty much 80%, and this happens more often when the system is loaded. So when we already test a lot, it's more likely to happen, and it especially happens very often on the test cluster node. So not where we are running KubeVirt to start virtual machines, but on the test cluster node. And Kind is nested and really starts every VM on the test cluster node because it's not really a VM in between like normally. So this is much more vulnerable to the issue which we see there. And another issue is that sometimes we have other issues, like, I don't know, on one node we have sometimes out of disk space for some reason. And since we're already close on the maximum, we have no spare resources to cope with such issues regarding to just taking off the nodes, or when we hit such issues and the tests start failing, they get just retried, but we're already on the limit for the resources, so it just sums up overall. This is kind of the current situation we're in. There are currently a few things going on to improve it again a little bit. One is to add more servers. I've just heard today that we probably get 3 more servers. This should help a little bit also to cope with such issues which just happen every 1 or 2 weeks. And I'm spending again time on this def null, def kvm permission denied issue and try to identify it, since that would also happen. This is basically the bottom line for it. So it's just want to say that it's known, it's annoying, it has a few reasons which we partially can control, partially not. But the tests really help a lot. Just identified yesterday 2 issues which are real in the KubeVirt code. Luckily, interestingly here, the overload on the CI system helps exposing them, but that of course doesn't help merging pull requests.
Well,
Yeah.
I'm glad there's an upside.
Can we actually say, Roman, that we would welcome any contributions from external companies to donate hardware to the KubeVirt project for further CI testing?
To be honest, I mean, it depends. It's really great from ARM, for instance, that they're sponsoring one node, or actually, I think Packet is sponsoring it for ARM, but still, it's great to get, for instance, an ARM server there, and we may probably also get PPC machines. This is very great and very welcome. For the core CI system, it would be great if money would be sponsored.
Oh, yeah.
Just
I think
buy
I
more
said
hardware.
that. Yeah.
No, you
To
said
rent
sponsor. Oh, yeah. If you mean with sponsor, give the money to buy to rent more hardware on the cloud which you have. That's great. Really sponsoring some nodes, that's not so helpful because things need to be closely co-located and all these kind of things to properly work with caches and so on.
I just wanted to note that that the IPv6 kind lane is supposed to be dropped eventually because we have it in the 118 lane dual stack now. It's going to get in, and then we can drop that one. So
Perfect.
It should help a little bit.
Yeah, it's one of the small pieces which together help a lot. Then it's great.
Okay, we are growing late in the hour. Are there any other topics today that anybody would like to raise? All right, thanks everybody. See you next week.
Bye.
Bye.
Thanks. Bye-bye.
Bye.